Hi, today we're going to be solving a redox problem, and we're going to do a couple things. Consider the reaction below, write half reactions, including electrons, and then also identify the chemicals that are oxidized and reduced. And don't forget, when we go to identify those chemicals are always reactants. So the first thing I want to do here, I'm going to tackle the half reactions. I don't have to do that, I could do the oxidation first, but let's look at half reactions. I'm going to assign oxidation numbers. So magnesium all by itself, metal, oxidation number of 0. Oxygen all by itself, diatomic, oxidation number of 0. Here in magnesium oxide, I see it's an ionic compound, and so I can go to the periodic table, and I know that from group 2, magnesium has a 2 positive charge, and group 6, oxygen has a 2 negative charge. So the next thing I'm going to do for a half reaction is I'm going to copy carefully, and I'm going to separate the elements. So 2 magnesiums turn into 2, and remember these were magnesium with a 2 positive charge. And then the other half will be the oxygen half, O2, turns into, and I can rewrite this as I have 2 oxide ions. So if I draw a little Lewis structure to help me see what's going on here with magnesium, magnesium when it's neutral has 2 valence electrons on it. And when it turns into an Mg2+, that means it lost those 2 electrons. So they were there, now they're going to be part of the product, which, if I notice, allows my right side here to be electrically neutral. 2 positives and 2 negatives equals the 0 charge that I had over here. Now, take note that 2 magnesiums turned into 2 magnesium ions. Down here I was just looking at 1 magnesium turning into 1 magnesium ion. So I actually need to do this whole thing times 2, which means I'm going to have 4 electrons from those 2 magnesiums. Alright, now looking over at the oxygen, if I had 2 electrons lost here, I know that I have to have, if I had 4 electrons lost, I need to have 4 electrons gained over here as a reactant. Okay? Does that make sense? Well, if I want it to be electrically neutral, I've got 2 times 2 negative gives me 4 negative on the product side, and then over here I have 4 negative, so 4 negatives equals 4 negatives, and that works out. And so those are my 2 half reactions. Electrons as a product here, 4 of them. Electrons as a reactant here, 4 of them. The last thing that I need to do is identify the chemicals that are oxidized and reduced, and I wrote my note to myself, those are going to be reactants. I can also remember my mnemonic oil rig, which is oxidation is loss of electrons, reduction is gain. Also in oxidation, I know that I gain oxygen. So if I look here, a couple ways to approach this. Magnesium gave electrons away, so that means they were lost, and that means that my reactant here, magnesium, when it was neutral, is oxidized. I could also say it was the reducing agent. Over here, oxygen gained those 4 electrons, and so I would say that O2 was reduced, or we could say it was the oxidizing agent. And I can see that another way up here in the reaction itself, actually. Magnesium, as it moved to the products, it gained oxygen, and so that tells me also that magnesium was oxidized. Okay, so just to recap, to write those half reactions, first I identified the oxidation numbers. Second, I broke it down by elements. Third, I added and removed the electrons, and those numbers needed to match perfectly, 4 electrons and 4 electrons. One side lost, one side gained, and then finally I was able to identify what was oxidized, what was reduced. Thanks, and thanks for watching.